Yes, sir. Good evening, everyone. A very warm welcome to all of you to another session of our industry-oriented training on Python programming for AI and data analytics. Over the past few weeks, we have built a strong foundation in Python programming, data analysis, statistics, and data visualization. Today, we begin one of the most exciting phases of this training program as we step into the world of machine learning. Today's lecture will introduce us to the core concepts of artificial intelligence, machine learning, deep learning, and machine learning workflow. We will explore how these technologies are interconnected, understand their differences, and learn how machines can identify patterns, learn from data, and make intelligent predictions without being explicitly programmed for every task. The session will also provide an overview of the complete machine learning workflow, from data collection and pre-processing to model training, evaluation, and deployment. Understanding this workflow is essential for anyone aspiring to build intelligent systems or pursue a career in data science, artificial intelligence, or machine learning. I encourage everyone to actively participate, ask questions, and relate today's concepts to Python, statistics, and data analysis techniques we have learned so far. Today's session will lay the foundation for practical machine learning topics that we will explore in the coming lectures. It is my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, Associate Professor at Waf Farid College of Engineering and Technology, Bathinda. Through his expertise in artificial intelligence, machine learning, computational sciences, and data analytics, he continues to guide learners with practical, industry-oriented knowledge and real-world insights. With great pleasure, I invite Dr. Meher Chand to kindly lead us into today's session. Over to you, sir.
Thanks, dear Face, for the nice introduction. And dear participant, good evening and welcome back in this session. Especially machine learning essentials. And this is the basically foundations of the machine learning with the hands-on Python. But before that, we have to clear the all concept, what we need and how we can do. Okay, so today our goal is not only to understand the theory behind the machine learning, but also to get the practical insight into how machine learning models are built and applied using Python. Throughout this session, we will start from the fundamental and gradually move toward hands-on implementation. By the end of the today's lecture, you will have a clear understanding of the complete machine learning workflow. And I have prepared one roadmap for the machine learning. Okay, what you need and how you can achieve this goal. So everything when we want to develop a model, we have to uh, understand first the roadmap, how we can start, what is our goal and how we can achieve. And to achieve the goal, what are the essential skills are required. I am audible?
Yes, you are audible.
Yes, sir.
Okay. So here we will talk about what is machine learning, AI machine learning, deep learning, types of the machine learning, data pre-processing. This part you all has done. Okay. Feature engineering, partially we have talked about this one, and our main part will start from train test split. This is the new part for you. Okay. So someone mic is unmuted. Please, I request Mr. Jatinder, please mute your mic.
No, sir, मेरा नहीं है sir. Not me.
Ishaq. Okay, just
नीचे
1
निकलना
minute.
नीचे निकल मिस्टर तुराइल
Okay, now it is fine. So during this session, I promise that there will be no question from your side. Okay, just you are required to the entire concept which I presented during the session. Okay, but if you are spending 1 hour with me, then please focus on the content which we are presenting so that this time 1 hour will be fruitful for you. Okay, so what we are going to cover here, regression and linear regression, model classification and logistic regression. Then we have the decision tree and KNN. Okay, so during the session, I will encourage everyone to actually participate and feel free to ask the queries, but you can put only in the chat box right now because you are not permitted to unmute your mic. Okay, so the very first is what is actually machine learning? Okay, so the machine learning is one of the core technologies behind today's intelligent system. Whenever you receive a movie recommendation on Netflix, product suggestion on Amazon, spam filtering in Gmail, face recognition on your smartphone, medical diagnosis using AI, or fraud detection in the banking. Machine learning is working behind the scenes. Okay, so all these models which we are using in our daily routine are based on machine learning models. Okay, and the learning machines equip you the ability to analyze the data, build predictive models, automate decision making, and develop intelligent applications that solve real world challenges. Okay, so this is all about why the machine learning and why we need. So here the basic we are required just like data pre-processing, feature engineering, regression and classification. Then we have the model evaluation. This is the main part. Okay, and for there some of the models which we have linear regression. You can see here 4 models are there which we define here. Okay, linear regression, logistical regression, decision tree, and k nearest neighborhood. Okay, so the you can see here our outcomes, learning outcomes when you will focus on entire session. What are the parts, how we can develop the model, what are the essentials. Okay, so everything we define very clearly, and I try to make the concept which we need to understand to develop this intelligent technology. Okay, so step by step, we have clearly defined here. Okay, so first, the objective of this lecture is to understand the artificial intelligence, machine learning, and deep learning. Then differentiate between the supervised, unsupervised, reinforcement learning. Then perform data pre-processing and feature engineering. Data pre-processing we have discussed in the previous, and also today we will talk about what is the feature engineering, how we can develop the model. So for that, we have to split the data, training and data testing. Okay, there are 2 parts. After that, we have to build the regression or classification model. There are several types. One of them we have to choose according to our the data set. And when our model is trained, then after we have to evaluate the machine learning model using the standard matrices are there. So by using them, we can evaluate our model, whether the model is performing accurately or not. Okay. Then after implement the machine learning algorithms using the Python and scikit-learn. And after that, we can have the model which we can deploy. So for the deployment, we are required again many skills, because here we are required to develop front end, just like you can see my desktop, and then backend where your model will work. And we have to connect on the desktop so that whenever we need to give the input, and according to the model which we have trained, give us output. Okay, so for that, multiple skills are required. How we can develop a website, or how we can develop a mobile application. Okay, so for these are required some different and advanced techniques. Okay, but most important thing is to establish the model. Okay, and you all will be able to establish the model. Okay, and please don't left the meeting, because at the end I will let you know the roadmap. I got some queries. What should we do now? Okay, so other things which you have done in the previous sessions. Okay, you have to complete all those tasks. Okay, but according to the data set, the problem which you have chose. Okay, so the criteria will be at the end when you will see the roadmap. Okay, what is the roadmap and how you can achieve your goal. So the problem is your goal which you want to perform. You have the problem, but now you have to follow all these instructions step by step. Okay, so the steps which we will discuss at the end are very, very essential for you. Okay, so AI is very a broad term. Machine learning is the subset of the AI because this is based on some data set. Okay, and deep learning again, we have the subset of the machine learning. So we will talk about all these the incomplete. So this is the introduction of the machine learning. Okay, so what we do in the machine learning model. So on the right hand side, you can see data collection. So first, according to the problem, we are required to choose the data set. Then data pre-processing, which you are required to apply all type of the just like data cleaning, data preparation, to understand the data set, to visualize, descriptive static, everything which you have done in the previous sessions. Okay, so all these, everything is not essential, but at least minimum so that you can have understanding about your entire data set. Okay, you are not required to visualize all type of the visualization. There are several examples are there I have put here, but you are required just like pair plot, then histogram, normalization, whether the data set is by using the KD curve. Okay, this will help you to understand the data set. You can use probability distributions, which we have discussed. Okay, so all these will help you. So then after when the data is cleaning, we are able to use it for the some statistical analysis we can do. Then learning from the data, we have to adopt a algorithm. Okay, so which we can use them, one of them. Okay, there are several algos are there for machine learning. Okay, we will discuss in the detail. And then by using one of them, we will train it. And for the training, there are some parts will be there. So one by one, we are going to cover. So this is the learning part. Okay. After that, when the model is ready, then we can use for prediction and insight. When model will be trained, we can use the model. Okay. So the simply, if we say the machine learning is a branch of the artificial intelligence that enables computer to learn patterns from the data and make prediction without being explicitly programmed. Okay, we are not required to write any program. Okay, so instead of the writing the fixed rule, ML algorithm learn from the historical data. Note this point. What is the meaning of a historical data? So the all the machine learning models, basically we can train from old data set which we have already. And by using the old historical data set, we will develop that technique, intelligent technique. And once the model is established, we can predict for the future problem. Okay, if we have any value which we are required for the prediction, we can use. So for the example, you can see here, we can use the model for email spam detection. We can use the same face recognition. Then we have the recommendation system, fraud detection, medical diagnosis, self-driving cars, chatbots. So all these are the examples of machine learning models. Okay, so the in the machine learning intelligence system, they learn, adapt, and make a decision to solve the real world problem. So we can easily train the model according to the problem. Okay, so here we have some differentiation between what is AI, then ML, DL. Okay, so you can see here, AI is artificial intelligence is a pro term. Okay, and machine learning is the subset of AI. And then DL is a subset of ML, as I told you in the very beginning. So here we have created three different columns. Okay, if we see according to the definition, so main purpose of AI is to make intelligent machines, and the machine learning learns from the data. Okay, so all the tools skills which are required for AI, here we are required only some type of the process are required. Okay, just like some data cleaning, reprocessing, then we spread the data in two part. Okay, then we will apply some algorithm, and on the that algo we will train the model. Okay, and after the training, when the model is trained, we can use it for prediction. But deep learning is different concept. Okay, so here learns using neural networks. Just like there are two type neurons are there. One is biological, just like our brain is working. Okay, we are observing something. We are taking the inputs by eyes, ears, or by touching the body. These are the inputs. Okay, so the signals are goes to in the brain, and then there is a semantic that will understand, and then after return the value. In the same way, in the case of deep learning, okay, the same thing will happen as our brain, but that is completely developed artificially. Okay, so there is many things signals are there, input is also there, then bias is required, summation function is there. Okay, we will discuss in the coming session for the deep learning, but here is just only the overview. Okay, then a summation function is required, whether the then after we have to use some hidden layers will be there. Okay, so according to the prompt, we have to use them, and then the model is trained, we can use it. Okay, so in that case, we are required, just like linear algebra, we are required derivative, partial derivative, okay, Jacobian. So on these are required. Some functions, just like sigmoid function. Okay, some functions are required, which are known as activation function. Okay, there are several examples of the activation function which are required for the deep learning. Okay, so in the second relationship, this is the broad field, and machine learning is the subset of AI, and deep learning is a subset of ML. Approach, this is the rule-based plus learning. And machine learning is completely data driven, because on the basis of data, if we have the data, we can train the model. Okay, and for the deep learning, we are required large data. Okay, and having various features are there. Okay, then techniques uses logic and reasoning, and in the machine learning, we use only algorithms. And in the case of deep learning, we have to use deep neural network. Okay, and examples you can see the chess AI, then example house price prediction, and in the case of deep learning, we have the image recognition. So image recognition or image processing. So these are the examples of deep learning. Okay, so here, then after types of machine learning, there are three categories. Okay, one is supervised learning, second is unsupervised learning, and third one is reinforcement learning. So when we are talking about the supervised learning, we have input as well as output. Okay, in our data set, we know, we understand. Okay, so we know input and output both. Okay, so this is the supervised. It's like you can see here, this is the input. Okay, where and the on the right hand side we have the output, and here is the model. So what we do here at this place we have the algo. Okay, so input like we have the independent variables, and output means dependent variable. So from the data set, we will train the model by separating the data set according to the conditions, which we will discuss right now. Okay, so the algo will be trained by using one model. And once the model is trained, then we can use the same for the future unknown values. Okay, so the algos which we can use for the supervised learning, you can see here linear regression, and all of you are familiar about the linear regression. Then we have the logistic regression, decision tree, random forest, KNN, SVM. So these are the models which we can use for supervised learning. Okay, for example, if you want to use for house price prediction, student marks prediction, disease prediction. So for this, we have the supervised learning. Okay, and at the bottom, you can see in the supervised learning, learns from the labeled data to predict. What is the meaning of labeled data? Labeled data means output. Okay, we know what is output on the basis of the input variables. Okay, sometimes the output will depend upon multiple variable. Okay, so what we have to do in that case, all the variables, the data set will be divided into two parts. One is X and the other is Y. Y is only the output variable. This is the labeled data. Okay, and what is X? Where Y is depend upon features. So features can be 1, 2, 3, 4, 5. So all the features or the independent data set, whatever we have, okay, will be stored in X variable. Okay, so then we have this is the input and this is the output. So two categories will be there, and from this we will train the model. Okay, and on the other hand, we have the unsupervised learning. Okay, so in that case, we have data but unlabeled. Unlabeled means we don't know what is output. Okay, this part is missing. We have only the unlabeled data. So in that case, our main objective is to get hidden pattern. Okay, suppose that we have three categories of the data, as you can see here. Okay, these are mixed with each other. You can see green, blue, and magenta color. Okay, so we need to what is the pattern inside the unsupervised unlabeled data set. Okay, so this can be used for just like customer segmentation. Many customers are coming to in the any shop or the market. Okay, but we don't remember any name. But the different type of the customers will be there. So this type of data we can use for uh, to get the pattern. Okay, just like we are all the peoples are using Amazon. Okay, Amazon website, and many people are visiting there. Okay, so when we give some input, okay, so various people's millions of the peoples are coming there to search some product. Some are searching mobile, there are different type of the categories. Some are visiting for clothes, some are visiting for laptop. Okay, many products are there. And according to that, Amazon will recommend the product. Okay, so the people's what they are doing. Okay, but they share some information. Okay, so according to they give the some input and they suggest something. Okay, they get some information. Just like if we are using WhatsApp. So when we are using WhatsApp, we are sharing our sentiments, our interest, etc. on any social media. So lot of information is there on social media like LinkedIn, like Facebook or YouTube. So all the informations which we are sharing there and the companies are getting some hidden patterns, what they are searching. Okay, what they are doing on the social media. From that place, which type of the information they are sharing, they get the trend and on the basis of which they are searching, they get the pattern in the which the information we share there. Okay, so from that we can develop the model. Third one we have is the reinforcement learning and learn by trial and error through towards and penalties, rewards and penalties. Okay, so just like for the you can see the application of robotics, games, and autonomous vehicle. Okay, so sometimes we can observe when we are using weather prediction. Okay, so what is there when the weather is accurately and they asking it is correct or not, thumbs up or down. The options are there. So if the weather is not according to the given prediction, okay, then we like or dislike it accordingly. Okay, so this is the penalty. We appreciate or de-appreciate. Okay, so according to our input. So these are the penalties. Okay, so reward is, so this is the, you can see the environment and here is the agent. Okay, so from the environment they are learning and we will reward or penalty according to their learning. If it is uh, you can say the positive, then we will reward. If the output is negative, then we will penalize. So just like a kid, you can take the example when very first time we learn a cycle or car. Okay, so if one is trying to learn the car and in the very beginning what happened, we have some type of small accidents, you can say. Okay, we can hit a cycle, we can hit a any tree or anything which is on the road. Okay, because we are training. And if we hit the ball, then what happened? We have penalty. What is the type of the penalty? Repair the car, loss of some part of the body of the car. Okay, so these are the penalties. So when we learn from the penalties, reinforcement, this type of the examples are reinforcement learning. Okay, so most of we are using the first two. Okay, if you want to train some robotics and games and autonomous vehicle, in that case we have to apply reinforcement learning. If you wanted to use for customer segmentation or market basket analysis, so we have to use unsupervised learning because and for that we have to use algorithms which are k-means, hierarchical clustering or PCA. So these are the algorithms. Okay, so our journey will start from the very beginning. This is the very easiest way. Okay, so once you will be able to use supervised learning when you have the data and you will develop some model, then this will be a little bit advanced. Okay, so you can apply this technique. And if you are interested to work on the other field, you want to use for the robotic or game, this type of the technique you want to develop, then you can go this level. But you have to start from this place because this is the very easiest part. Okay. So here, this is the complete procedure. This is the complete procedure for the machine learning. Okay, so for the data pre-processing, so what you will do when you are getting some data, data usually will contain missing values, duplicate values, incorrect data, outliers, noise. So all these we have to improve. We have to remove the missing values, or we have to fix the values. If data is incorrect, we have to prepare. So this thing we have already discussed. We discussed about the outliers. We have discussed about the incorrect data. Okay, we discussed about the duplicate data. Okay, and we discussed about the missing value. What is the meaning of incorrect data? Just like we have gender category. Okay, there. So when someone will fill the information, male and female. Okay, so the error type, just like you can see, someone will use male, all the characters are in the uppercase. Someone are using all the characters in the lowercase. Someone are using M in uppercase. Okay, so only male, 3 type of the variables has generated. Okay, so this type of the errors we have to remove first. We have to understand the data set. Only then we can improve the model. Okay, so this will help us to improve the model accuracy. Okay, so here you can see when you get the raw data, and we can use a CSV file, we can use Excel, SQL, APIs, etc. Okay, we will import it. So this is the first part, and all of you are doing. Okay, second is handle the missing value. Also detect the missing value, impute or remove the missing data is null by using these functions we have discussed. Is null dot sum. Okay, df dot filna by using df dot main. If you have the small data set, we have to fill the values. Okay, so there are different ways to use it. Then we have the remove duplicates. If there is any duplicate value, we have to remove. Okay, then we have the encode categorical variables. For that, for male and female, we are encode 0 and 1, because when we will implement a statistical model, or you want to use any algorithm, so this will understand only the numerical values. So if there is non-parametric values, non-numerical values, we have to convert these values into numerical. Okay, then we can have the feature scaling. Okay, we will talk about the feature scaling in the detail. So the scale features to the same range for better model performance. Okay, we can use it just like these are the functions, just like a scalar and min max scalar. Okay, just like sometimes we have the data set and there is a large variation in the amount of the data. For example, we can see the income. Okay, so suppose that someone has the income per month is 10,000. Some are there 50,000. Some are there 1 lakh, 2 lakh, 3 lakh. Okay, so in that case, we can use minimax scalar. Okay, there is a formula. Okay, x minus minimum x upon maximum x minus minimum x. The formula is given here in the coming slide. So by using that, we can scale the values. So by using this one, all the values will be converted lies between 0 and 1. Okay, so this will not affect our model, but make fast, less consumption of the space. Okay, then we have the feature scaling, just like suppose that we have the patient data we discuss in the healthcare data set. So the patient admission and patient discharge. Okay, but in that data set, we don't have how long the patient was stayed during the treatment. So what we do, we will calculate the days duration, how long the patient was stayed or admitted. Okay, so for that, the date of admission minus date of discharge. So we have the days. Okay, so this will help us for to apply our and for the accuracy. So this type of operations, sometimes we are required to divide in the groups. Okay, and group by data also we use, but here to make more intelligent, we can divide our data set according to the age factor, just like 10 to 20, then 20 to 30, 30 to 50, 50 to 70, and 70 to 90, according to your interest, your way. Okay, so that also make our model more accurate when we have the grouped data. And then the last one we have is the separated data set. So the data set we have to divide in two part. Okay, suppose that we have 10,000 data set. So we have to divide this data set in two part. One is train, other is test. For the training purpose, we need a large data set. So this we can take the range from 70-30, 70% data set we are using for the training and 30% for the testing. We can use 75 and 25. 75% of the data will be used for the training the model and 25% will be used for testing the model. We can use 80%, 20%. Okay, so here you can see train, test, separate, and test size we are using here is 0.2. 0.2 means 20%. The 0.2 means 20%. So the 20% of the data set, whatever we have, we are using for the testing purpose. Here the term is test size. So this is the test size, which is 0.2. So the remaining data set, which is 80%, we are using for training. Okay, so if we have 10,000 data entries, then 2,000 will be used for testing and 8,000 will be used for training. Okay, so what are the purpose of all these operations which you will apply before training the model? So this is the benefit you can see: improve the model accuracy, reduce training time, reduce the overfitting and the errors, ensure data consistency, and better prediction and insight. So these are the benefits when you will apply these operations. Okay, so now we have the feature engineering. You can see here the example. Feature engineering means creating useful input variable from the existing data set. We are creating new variable. Okay, just like I taken the one example, we have the patient admission date and discharge date, but there is no time duration. How many days the patient was stayed? For that, we calculate the duration of the patient who was stayed in the hospital for the treatment. The simple way is you will use the formula date of admission, sorry, date of discharge minus date of admission. Okay, so we have the number of the days. This is the new variable. And you saw in the last lecture, this operation we have applied on patient data. Okay, so this is the feature. So according to our need, we can apply. So here is the one example you can see. This is the original features. In the first we can see the feature, and here is the description. Okay, date, here you can see the full date. Then salary, we have numerical values. Okay. And age, we have the numerical values. And when you will apply the feature engineering, what you will do? You can, here we are, the dates are given. Here we will, the new feature. What are these? Month, year, salary category, age. Okay. Description, you can see 5 month. Okay. So here we are given the full date from which we are starting. Okay. Dates are given, but we will convert in the months. We can convert, we can extend the years. We can divide the salary, okay, according to in the 3 categories or 4 categories, just like high, medium, and low. Okay, you can divide in 3 categories or 4 categories of the salary. So this will make more intelligent tool. And similarly, age group. Okay, so if we have that, here is only the one age, but here we are using age group. Okay, so you can take the age group just like 20 to 30, 30 to 40, and 40 plus. Okay, so these are the age group. So this will help us to make more accurate and these are the benefits you can see at the last column. Okay, relevant features help the model learn and the right pattern and improve the prediction accuracy. So this will help us to make fast learning. Okay, well engineered feature reduce the complexity and help model train faster with better convergence. And last one, reduce the overfitting. So many meaningful features reduce the noise and redundancy, leading to the better generation. Okay, so if you have the raw data, just like messy, raw, and unstructured, so by using the feature engineering, just like by using transform, create, select the most useful features, etc. So this will have the by using the feature engineering, we have the better model performance. Okay, more accurate, faster, and better real world performance. So this is the main feature engineering. What is feature engineering? And we will use in our real data set. Okay. So if we have, I think we have discussed about the feature engineering also in the last session. I know. Okay, we have covered this part. Now, this is the most important part, which is essential to understand when you will apply any machine learning model. Okay, so this is the way how we are applying and what will be the parts. Just here, like you can see here, machine learning model should never be tested on training data. So very first we have the typical split. From this place, we are going to start our learning, our machine model. So the training data set we are using 80%, and for the testing we are using 20%. So this is the original data set. Okay, this is the original data set. So this part, which is the 80%. So on the basis of this 80%, and this will be taken randomly. Okay, not only the first 80 or last 80 or 80% from the middle. This 80% will be taken randomly. And we will use the random term there when we will apply. Okay. And this data set we are using to train the model. One of the model we will choose and we will implement here to train the model. After that, when the model is trained, we will evaluate by testing. Okay, test on 20%, which the data set is left. So after training, the testing will be on the basis known value. Okay, input data and output data for both. Okay, whether the values which the model which we have trained, whether it is correct or not. So that can be possible tested when you will apply the X value, whether the Y value is accordingly is coming or not, according to your data set, where the model you have applied, and what are the accuracy. So for that, we have to evaluate our model. Okay, so this is the Python code which you can see here. So this statement which you can see, this is the sklearn model underscore selection import train underscore test underscore split. So this statement will be there always to split the data set. And these libraries are required: train, test, split. And you can see here we are using. So there are two parts. One is xtrain, xtest, ytrain, ytest. So always we have to use this term, this statement as we are using here. And now here you can see only there are two variable, one is X and other is Y. Test size we are taking here is 0.2 and random state 42. So that this value which we are using here 42, this is the not any fixed value. We can use any value which is greater than 0. 0, 1, 2, 3, 4, 0. Mostly we have 0, 0, 1. Okay, and any value we can use. So you can take 42, you can take 40, you can take 41. Actually, this will fix the random values. So next time when you will execute, the same data set will be taken here. And the test size you can see here, 20% data for the testing and random state assuring the reproducibility of the result we are using. So this is the graphical representation here and Y split. So preventing the overfitting, ensure the model generalizes well to new data, realistic evaluation. Okay, then we have the better prediction and efficient use of data. So this is all about the why we split the data set. Okay. So these are the models. Okay, so just like very first is the regression model, and we all are familiar about all these. So these models we are required to go through. So this part you can easily go, okay, because this is the not new thing for you. Everyone are familiar about this regression. Okay, so there are types. Linear regression is there, polynomial regression is there, Ridge regression is there, and lasso regression are there, and their functions how you can use. And these are the some evolution matrices. Okay, so MAE, mean absolute error, and formula is given here. MSE, mean squared error, this is the formula. Okay, and RMSE, this is the root mean squared error. Okay, it's a square root. Okay, in the same unit as target. And this is the R square score. This is the formula 1 minus summation yi minus yi cap. Yi is the original mean and yi cap is the predicted value. Okay, so these are the some formulas. So dear participant, sorry, I will not able to present the other slides. Linear regression, classification, logistic regression, dysentery, k-nearest, and conclusion. You will come to read all this remaining part. Okay, so that this we will discuss in the coming session. And now it is time because my next session is going to start now. Okay, so if I have left only 4 minutes. I have only 4 minutes. I will share this PPT with you. Okay, so if you have sorry, I was muted. I am asking if you have any question, please. Okay, at your face, please conclude the session. And these files I'm going to share with you in your WhatsApp group. I left only 2 minutes. So tomorrow we will start from the models which we can use in our machine learning. Dear face, are you there?
Okay, sir.
Okay. I think he left. Okay, no problem. So, dear participants, okay, thank you and good night. Tomorrow we will start the session at the same time. Okay, and good night. The content will be available in your WhatsApp group.